Good morning, all of you. I completed the vertical alignment like gradient and types of vertical curves in the last session. Today I will proceeding with the next topic, that is calculation of length of vertical curves. Okay. Firstly, I will move with the calculation of length of summit curves. First, calculation of length of summit curves. We know that there are two types of vertical curves, that is one is summit curves or crest curves with convexity upwards, another one is valley curves or sag curves with concavity upwards. Okay, and the one of the major problem in the design of summit curve is the adequate sight distance. Okay, that's why for the summit curve they are going to prefer a circular curve rather than the transition curve, because in the circular curve, okay, the sight distance available, okay, throughout the length of the road is constant. In circular curve, or we can call as parabolic curve, the sight distance available, okay, throughout the length of the road is constant. That's why, okay, they are going to prefer a parabolic summit curve or a circular summit curve. Okay, and usually the parabolic summit curve is designed, okay, for two criteria. One criteria is for stopping sight distance, another criteria is for intermediate sight distance or overtaking sight distance. Is it clear? Okay, we can design the parabolic summit curve either for stopping sight distance or for overtaking sight distance. Is it clear? Okay, we are going to design the length of summit curve, a parabolic summit curve for two criteria or for two things. One, it is, okay, for the stopping sight distance SSD, and the second one, it is overtaking sight distance OSD or ISD, intermediate sight distance. Okay, where overtaking sight distance cannot be provided, in that case they are going to provide the intermediate sight distance that is equal to twice the stopping sight distance. To provide the limited overtaking opportunities, okay, they are going to provide at least intermediate sight distance when it is not possible to provide the OSD, that is overtaking sight distance. Okay, firstly I will take up with the length of summit curve, okay, to fulfill the stopping sight distance. Okay, for SSD, okay, for stopping sight distance, okay, the length of the summit curve will be calculated in two different cases. Okay, the first case is length of summit curve greater than stopping sight distance, where L is the length of summit curve and SS is the stopping sight distance. We have to assume length of summit curve greater than the stopping sight distance. Okay, using this assumption you are going to calculate the length of summit curve. Is it clear? If this assumption is wrong, then they are going to use the second case, that is length of summit curve is less than stopping sight distance. Okay, firstly always we have to use the assumption length of summit curve greater than stopping sight distance. Okay, for the length of summit curve greater than the stopping sight distance, okay, your length of summit curve is equal to, it is ns square divided by 4.4. n square divided by 4.4, where n is the deviation angle. We know that the deviation angle is the algebraic difference between the two intersecting gradients. Algebraic difference between the two intersecting gradients, and s is the stopping side distance. S is the stopping side distance. Okay, if you use this relation, you may get the length of summit curve in terms of meter. And if this assumption is right, means this assumption is correct, means whatever the length of summit curve, we get it from this equation, that is n square by 4.4, it is more than the given stopping side distance, then the assumption is correct, then that length will be adapted as the length of summit curve. If the assumption is not correct, or if the assumption is wrong, means the length of the summit curve calculated by this equation is less than the given stopping side distance, then we are going to use the second case. What is the second case? For the second case, it is assume L is less than stopping side distance. Assume L is less than stopping side, means length of summit curve is less than stopping side distance. For this, we have an equation for length of summit curve. L is equal to 2s minus 4.4 divided by n. 2s minus 4.4 divided by n, where s is the stopping side distance and n is the deviation angle. Okay, and the length of summit curve obtained from this equation, okay, is less than the stopping side distance, then the assumption is right or assumption is correct. Okay, that length will be adapted as the length of summit curve. Of course, when the first condition is not satisfied or the first assumption is wrong, okay, obviously the second assumption is correct only. Okay, then whatever the length of summit curve we get from this equation, okay, that will be adapted as a length of summit curve, and usually you are going to round off to the whole number, next whole number. You have round off to the next higher whole number if you get the fraction. Is it clear? Okay, this is regarding the for stopping side distance criteria. Okay, for overtaking side distance or for intermediate side distance, for OSD or ISD, for overtaking side distance or intermediate side distance. Here also there are two assumptions. First case, we have to assume length of summit curve greater than overtaking side distance or intermediate side distance. Okay, for this assumption, the length of summit curve will be calculated from the formula, that is ns square divided by 9.6. L is equal to ns square divided by 9.6, where n is the deviation angle and s is the overtaking side distance or intermediate side distance. Okay, and whatever the length of summit curve we get it from this equation, if this length of curve summit curve greater than the overtaking side distance or the given intermediate side distance, then assumption is correct. Okay, that length will be adapted as the length of summit curve. But if the length of summit curve obtained from this equation is less than the given OSD or ISD, then the assumption is wrong. Then we can go for the second case, that is length of summit curve less than OSD or ISD. Okay, in this case we are going to calculate length of summit curve by using 2s minus 9.6 divided by n. 2s minus 9.6 divided by n. Obviously, when the first condition or the first assumption is wrong, okay, the second condition is correct only. Okay, whatever the length of summit curve we obtain from this equation, okay, that is second case, that will be adapted as the length of summit curve for the given overtaking side distance or for the given intermediate side distance. Here also, usually we are going to round off to the next higher whole number. Okay, this is regarding the calculation of length of summit curves, okay, for the stopping side distance and for the overtaking side distance. Is it clear? Okay. Next I'll move on to the numericals on calculation of length of summit curves. Okay. Numericals on length of summit curves. First problem, the first problem it is a vertical summit curve is formed at the intersection of two gradients plus 3 and minus 5%, that is ascending gradient of 3% and descending gradient of minus 5%. Design the length of summit curve to provide a stopping side distance for a design speed of 80 km per hour. Assume other data. Okay, it's a very simple problem. Okay, they have given plus 3% and minus 5%. It is plus, it always indicates ascending gradients and minus is always indicates descending gradients. Okay, first write down the given data. Given data, what they given? They given N1 is equal to plus 3%, that is plus 0.03. Percentage in terms of fraction it is divided by 100, no, 0.03, 3% becomes 0.03. N2 they have given minus 5%, it is minus 0.05. They have given speed of the vehicle V is equal to 80 km per hour. Okay. You may observe here, they are asking you to design the summit curve, design the length of summit curve to provide a stopping side distance. But they are not mentioning anything about the value of stopping side distance. They are not given the value of stopping side distance. Okay. But they are given the speed of the vehicle and they have included in your problem statement, assume other data. Okay. So in that case, we have to assume the suitable requirements or suitable elements to calculate the stopping side distance for your respective design speed of 80 km per hour. Okay. First you need to calculate the stopping side distance. Okay. Solution. First one it is determination of SSD. SSD is what? Stopping side distance. We have SSD is equal to Vt plus V square by 2Gf. Vt plus V square by 2Gf, where V is the design speed in terms of meter per second, T is the reaction time of the driver, and G is the acceleration due to gravity, that is 9.8 meter per second square. F is the coefficient of friction or the longitudinal friction. Okay. Assume T is equal to 2.5 seconds. 2.5 seconds. Always the reaction time of the driver, it is 2.5 seconds for stopping side distance. Okay. It was recommended by Indian Roads Congress. And F is equal to 0.35 for V is equal to 80 km per hour. For design speed of 80 km per hour, the coefficient friction F is equal to 0.35. Okay. And if you convert the V in terms of meter per second, they are given in terms of kilometer per hour. If you convert the V in terms of meter per second, then it becomes how much? That is 80 divided by 3.6, you may get 22.22 meter per second. Is it clear? Then if you substitute the elements in your stopping side distance, we get stopping side distance. Okay. Therefore, SSD is equal to Vt, that is 22.22 multiplied by 2.5 plus V square 22.22 square divided by 2 into 9.8 multiplied by 0.35 multiplied by 0.35. Okay, so 22.22 multiplied by 2.5, you may get about 55.6, and 22.22 square divided by 2 into 9.8 multiplied by 3.5, you may get about 72. Okay, if you sum it up, you may get about 127.6 meter, say 128 meter, because always round off the stopping side distance and the overtaking side distance to the next higher whole number. Okay, you may get 127.6 meter, say 128 meter. Okay, this is regarding the stopping side distance. Next, go for the length of summit curve. Length of summit curve. Okay, assume length of summit curve L greater than stopping side distance SSD. Length of summit curve greater than stopping side distance. Okay, for this we have length of summit curve L is equal to ns square divided by 4.4. Okay, n is the deviation angle, s is the stopping side distance. Okay, but n is equal to, we know that the deviation angle is the algebraic difference between the two intersecting gradients. Okay, n1 is about 3% and n2 it is 5%. Okay, if you want that, plus n1, because ascending gradient, algebraic difference means minus. Okay, minus n2, it becomes n1 plus n2, n1 plus n2. Okay, so n1 it is 0.03 and n2 is 0.05. so if you sum it up, you may get 0.08. 0.08 is the deviation angle. Okay, and majority of people, they are going to do the mistake here only. They are going to sum it up the gradients, okay, in terms of percentage itself. Okay, 3 plus 5, you may get 8% like that. Okay, don't compute the deviation angle n, okay, in terms of percentage. Always you should use in terms of fraction. Okay, you may get about 0.08. Therefore L is equal to, n is 0.08, no, 0.08. S is, it is the stopping side distance, you may get 128 square divided by 4.4. Okay, you may get about ns square divided by 4.4, that is 0.08 multiplied by 128 square divided by 4.4. Okay, you may get this about 297.9 meter, say 298 meter, say 298 meter. Okay, as this value, that is 298 meter, is greater than the calculated stopping side distance of 128 meter, then the assumption is correct. Then the assumption is correct, means the L is greater than stopping side distance. No, we get the length of summit curve 298 meter and your stopping side distance is about 128 meter, means the 298 meter is greater than 128 meter, then the assumption is correct. Therefore, the design length of summit curve is 298 meter. Okay, as this value higher than or greater than stopping side distance, the assumption is correct. The assumption is correct. The assumption is correct. Okay, therefore the design length of summit curve is equal to 298 meter. Therefore, the design length of summit curve is equal to 298 meter. Is it clear? Okay. This is regarding the length of summit curve. Okay, to fulfill the or to provide the stopping side distance of 128 meter. Okay, sometimes they only given the value of stopping side distance. Okay, then you may eliminate this step, determination of stopping side distance. You can eliminate directly. You can go from the length of summit curve, from the calculation of length of summit curve. Suppose if this assumption is wrong, means the length of summit curve is less than SSD, then we are going to use the second case. Okay, that is L is equal to 2s minus 4.4 divided by n. Okay, next I will move on to the second problem. The second problem, it is an ascending gradient of 1 in 100 meets a descending gradient of 1 in 120. A summit curve is to be designed for a speed of 80 km per hour. So it has to have an overtaking side distance of 470 meter. First, write down the given data. What are they given? They given an ascending gradient, means n1 is equal to plus 1 in 100, that is 1 by 100. n2 is equal to minus 1 by 120. Okay, and they given v is equal to 80 km per hour, and they given overtaking side distance OST is equal to 470 meter. Okay, go for the solution. Calculation of length of summit curve for overtaking side distance. Okay, first case, assume length of summit curve is greater than overtaking side distance. Okay, for this we have an equation ns square divided by 9.6, where n is the deviation angle and s is the overtaking side distance. Okay, but n is equal to what? They have given the ascending gradient followed by a descending gradient. It is the third case of summit curve. Then it is becomes n1 plus n2. Okay, this algebraic difference between two intersecting gradients, it becomes n1 plus n2. No, that is 1 by 100 plus 1 by 120. Okay, you may get this about 11 by 600. May get this about 11 by 600. Okay, therefore, how you get 11 by 600? Very simple, no? So 120 plus 100, you may get 220. Then 100 into 120, you may get about 12,000. 220 divided by 12,000. Okay, if you use a 20 as a divider, then 20 11 ja it is 220, and 20 600 ja it is 12,000. Okay, then we get 11 by 600. Therefore, L is equal to n is 11 by 600. N is 11 by 600 multiply S is 470. S is 470 square divided by 9.6. Divided by 9.6. Okay. Then if you compute this, you may get about 418.9 meter. 418.9 meter. Is it clear? And you may observe here, as the length of 418.9 meter is less than the overtaking side distance of 470 meter, then the assumption is wrong, because we are assumed that length of summit curve is greater than OST, but here the length of summit curve is less than OST. Your OST is 470 meter and you get about 418 meter as the length of summit curve. Then assumption is wrong. Okay, as this value less than OST, the assumption is wrong, or we can call as incorrect. Assumption is wrong or incorrect. Okay. Next, in the second case, I am going to assume L, the length of summit curve is less than overtaking side distance. Okay. In that case, the length of summit curve will be calculated by 2s minus 9.6 divided by n. 9.6 divided by n. Therefore, L is equal to 2 into 470 minus 9.6 divided by n. N is about 11 by 600. No, 11 by 600. Okay. Using this, you may get about 416.4 meter, say 417 meter, say 417 meter. Okay, and as the 417 meter is less than the overtaking side distance of 470 meter, the assumption is correct. Therefore, the design length of summit curve is about 417 meter. Okay, as this value is less than OST, the assumption is correct. The assumption is correct. Therefore, the design length of summit curve, is equal to 417 meter. Design length of summit curve is equal to 417 meter. Okay, this is regarding the length of summit curve to fulfill the or to provide the overtaking side distance of 470 meter. Okay.